Welcome to Shane Hare's Roundabout system test. The client Sally has requested the design of a roundabout system that is able to generate controlled angular velocities. The following video will outline the major design and manufacturing processes involved in constructing the roundabout system. In addition, 5 test procedures will commence, which aim to test the accuracy of the roundabout. The program system design consisted of 3 major parts, including setup, control, and correction. The general goal of this design was to use 2 control cycles to ensure a particular angular velocity was reached. This involved moving the servo motor and recording its angular displacement twice so that an average velocity could be checked against the desired angular velocity. If the 2 values did not match, the servo motor delay time would be changed in order to achieve the desired angular velocity. The design of the roundabout consists of 3 major sections, including the stationary base, the rotating disc, and power transmission. The original design contributed a flat belt drive system that generated a power ratio of 2:1. This was done because the servo was limited to 180 degrees of turning freedom, which was not ideal for a full rotating system. After consideration and experimentation, it was decided to use a gear drive system instead of a flat belt drive system, so as to minimize the risk of slipping, which would decrease the accuracy of rotation. In hindsight of the roundabout system design, the manufacturing process consisted of 7 major steps. Firstly, all major components were cut and appropriate holes were drilled in order for the shafts to fit. Secondly, the 4 40mm long base legs were fitted into the outer holes of the base plate and glued in place. Thirdly, the gear drive as well as the 10mm center shaft were fitted and glued into the center hole of the rotating disc. Fourthly, the 10mm drive shaft, circular connector, and servo motor holder were fixed together using glue. Fifthly, the assembled drive shaft was slotted through the base plate into the gear drive with a metal washer between to minimize friction. Sixthly, the driven gear assembly was placed on top of the gear drive and base plate. It should be noted that another 6mm metal washer was placed in between the driven gear assembly and base plate in order to minimize friction. Lastly, the base plate and attached rotating disc was placed on top of the servo motor whilst the legs were fixed to the ground. Now that the roundabout system has been assembled, the testing procedure can commence. Firstly, Test A experimentally tested the ability of the servo motor to turn 45 degrees and 160 degrees. As it can be seen, the servo motor was successfully able to turn 45 and 160 degrees. It should be noted that the servo motor was not able to successfully complete a full revolution. This could be due to multiple reasons. However, the presence of friction within the gears could be the cause of limiting full rotation. Secondly, Test B experimentally tested the ability of the motion sensor to measure changes in angle as the roundabout spun. Through the use of the serial monitor, the gyro angles along the z-axis were displayed as the system turned at the specific angular velocity. From the serial monitor, it can be seen that the gyro sensor was successfully able to record the change in angle. It can be seen, however, that the change in angle was not as smooth as anticipated. This could be again due to multiple reasons. However, the The initial inertia of moving the disc could be the cause of sudden changes in angular displacement. Thirdly, Test C experimentally tested the accuracy of the roundabout system when subjected to weight. To test this, 20-cent coins were stuck to the top of the board. As it can be seen, the average velocity of the roundabout was roughly equal to the desired angular velocity specified in the code. The position of coins on the outside of the board could be the cause of slight inaccuracy, as unequal moment caused the board to slightly oscillate. Fourthly, a different angular velocity value was inserted into the Arduino code, which was slower than the original. It can be seen that the average angular velocity was roughly equal to that of the input value. Lastly, erratic movement was induced onto the roundabout system in an attempt to decrease the accuracy of the system. This was done using a 30cm ruler to lightly tap the top surface. It can be seen that the average velocity was not heavily affected, thereby proving the reliability of the system. From these tests, the roundabout system was proven to produce accurate results despite inducing weights and erratic movement. Anomalies encountered during the test procedure included slight differences in average velocity and the limitation of not turning 360 degrees. This was mainly due to the build-up in friction between the underlying parts.